Hello, EFR students. This is example manuscript STEM analysis part 2. Part 1 is about a 15-minute video that's already been posted. And to start off where we left off, what we want to look at is our survey. And in our survey, we had a research question here that was Q1, a career in STEM could give me the lifestyle I want. And it was yes or no. And we were comparing it to the two different constructs in the paper. So, so it's very important that we know what the codes were. So no is coded as 1, 2 is yes is coded as 2. So coming back to the manuscript here, we want to go ahead and do the t-test now because we've done descriptive statistics of some form of agreement, means and standard deviations. We came down here and gave our Cronbach alpha measures of internal consistency. And it happened that confidence in science was 0.77 and ability to succeed was 0.82. If yours aren't like this or even negative, that's not necessarily good, meaning if you have a zero point 0.4 here or a 0.3, it means your items didn't demonstrate much internal consistency. For the purpose of this project, don't worry about it because this is about process more than actual content. But and we'll follow up with that in 516. So, so then we did the correlations, and we came up with 0.69, these correlating. That depends. You'll talk about that in your paper if that makes sense, that the independent constructs of confidence and ability are correlated or not. But when we did that correlation, we created our constructs by summing them. Now the next question we want to address is our key main question. That being that when we look at the question, a career in STEM could give me the lifestyle I want. And what we wanted to know if somebody that said yes to that, for example, had higher confidence and and higher ability, meaning they rated themselves with higher confidence, higher ability, and is there association with that with believing that it could give you a career that fits their lifestyle. So, so the purpose of this study was to assess if there was an association between girls that thought that a career in STEM could give them the lifestyle they wanted based on their perceived confidence in science and perceived ability to succeed. So we're going to address that with independent sample t-tests. And I've done it here, and I just did it in one paragraph. It turns out I didn't find evidence, statistical evidence. Obviously, the sample there is a difference, but I don't have statistical evidence. You may or may not in your study find statistical significance. So in the first one, for confidence, the mean response for those girls who said yes, that a STEM career could fit their lifestyle was 5.2. Now we're on this 1 to 6 scale, where 6 is strongly agree and 5 is agree. So we're somewhere in between agree and strongly agree. But for those who said no, it was only 5. So it's not a big difference, but they did have less perceived ability and less perceived confidence. But was it statistically significant? It was not. So the difference was not statistically significant. T40 equals minus 0.962 comma P greater than 0.05. So the key aspect of reporting on this is telling me that what test I used, the degrees of freedom, its value, and then the probability of that value under the null assessed against your type 1 error rate. So in this case, my type 1 error rate was 0.05, and the p-value I got from my two-tailed test that I conducted was greater than 0.05, so I'm not statistically significant. And likewise, we do that for ability here. So let's go through how we're going to conduct that test in SPSS. So we'll open up our data, and we'll go ahead and do confidence first. So, or let's do them together. So we'll go analyze, general, compare means, independent sample t-test. Let me do that one more time. We're going to go to analyze, compare means, independent samples t-test. We have independent samples because we have those that selected yes and no for question 1. So go ahead and click on that. And we're going to go ahead and put our test variables in there, or our dependent variables of confidence and ability. We can put them both in. We'll do them both at the same time. And then our grouping variable that we're breaking these two groups up into independent groups was question 1. So put that in there, and then we need to define it, and we defined it in terms of 1 and 2. So we've defined it as groups 1 and 2. I press continue. Okay, so now I'm ready to go ahead and run this test. So I'm going to say OK. And we get the results out here now. So if we look at confidence, we see that the mean for those who selected 1 was 4.9697, and those who selected 2, 5.2366. Okay, so we're going to round this. So we're going to round this 4.96 up to 5, and we'll round this one for 2 up to 5.2. Okay, so why don't I just go ahead and bring this over? So I'm going to copy special. There's different ways to copy it. I like to copy it in as a meta file. And I'm going to paste this right into my document here so we can look at this more closely. Okay, and then I'm going to go get the other one then as well. You don't have to paste yours in. Okay, I'm just doing this so we can talk through the analysis. Okay, so I'm going to come and then I'll paste that right into the document here. Okay. All right, so when you paste them in as images, you can scale them nicely, scale them a little easier in that process. So, okay, so, and let's go back and remind ourselves how we coded these, and I'm going to copy that in as well. Okay, so coded 2 as yes. Okay, so as they believe it, and no as 1. Okay, so where I got this information from then is up in the means up here. It's good. Go ahead, and I'd like you to do that. State your means. So the means yes that they could is coded as 2 right here, and it's 5.2. M equals 5.2, and I got it right up here. 5.2 coded 2 as yes, and those that said no, which was coded as 1, we rounded that to 5. So we got those here. The difference was not statistically significant. How did we find that? So here we're looking at confidence. See confidence right here, and we won't work with the confidence interval, so I'm going to go ahead and blow this up a little bigger here. Okay, this is all we need, and a little bigger. Okay, so the first thing we see in the output is we have our two rows, confidence and ability. We're just working with confidence right now. The Levine's test, one of the assumptions of the t-test is of quality of variance in the two groups. So for those selecting yes and those selecting no, the variance is the same. We would like this to be not statistically significant, or we'd like the sig value to be greater than 0.05 if your type 1 error rate is 0.05. So generally that's the case unless something odd's happening. So we're going to go ahead and use equal variance assumed in this top row. Okay, so then the first thing we see, it's a t-test, it's degrees of freedom, and the sig, which is for our two-tailed, assuming you're doing a two-tailed test, as 0.357. If you're doing a one-tailed test, then what you need to do is say, did it go in the right direction? Say if I predicted the people saying yes would have higher ability or higher confidence, you see, did that actually happen? Right? So yes is coded as 2, so 5.2 is higher than 1, so it did go in the right direction. And then you divide this sig two-tailed divided by 2, and then that would be your p-value. So it's a two-step process when you do one-tailed tests, if you're doing those. But here I did a two-tailed test. So I know my sig here, two-tailed, is 0.357. My type 1 error rate, which is commonly 0.05, be wrong 1 in 20 times, assuming the null is true, that I see this is greater than 0.05. Okay, so then that's how I wrote it here. It's a t, so I start out with a t. Let me maximize this. Let me increase this size so you can see it. Okay, so right in the text here, I have a t, right? See this right here, and it had 40 degrees of freedom, so parenthesis 40, close parenthesis, equals, what was the value of the t? It was 0.9 minus 0.932, write that down. And then p comma greater than or less than my type 1 error rate. So this is my type 1 error rate, 0.05. And mine was right here, sig 2 tail greater than 0.05. There's also the option in APA to go ahead and say P equals 0.357. That's acceptable as well. And then tell me what your type 1 error rate was for that test. In my mind, this is just simpler. Smaller p-val doesn't mean more significant. What you want to know, did you pass, did you reject the null or not? And that's all I do. In courses like 516, we'll go on and we'll calculate the effect size colons D. But for this assignment, we don't have to do that. Okay. So now for the next one, for the difference is not statistically significant. So when we're looking at ability here, then we'll go to ability, and I'm going to go look at my sig two-tailed and look at its 0.053. It's almost there, right? But it's not. We fail to reject because it's not less than 0.05 in that sense. So the means there, the means for the ones coded yes, which was the 2, was 5.06 up here. See up here, and we'll round that to 5.1. So it's 5.1 right here. And then the for those who said no, it was 5. It rounds to 4.5. And then the t, let's look at the t. It's a t, again 40 degrees of freedom. Its value was equal to minus 0.1997. We're going to round that to 2. And the p-value was greater than 0.05. So that's this result right here happening in our analysis. Okay, so that's it. So I'm stuck in this case in not being able to talk a lot because I don't have evidence. The key here is we don't know that there's not an association, but we don't have evidence because we're failing to reject the null in that sense. So that's kind of the conclusion here. So discuss it and then move into your discussion. You should summarize your results in relationship to your research question. Ours was per that question dealing with lifestyle. Okay, and although the sample showed that the students um, that students thought that a career in STEM could give them a lifestyle they wanted, had higher agreement with confidence in science and ability to succeed, neither comparison was statistically significant. So indeed, the sample was consistent with our hypotheses, but we didn't pass the test of chance. So we don't know about the population. So we're not necessarily talking about that. So that was kind of the summary here. Uh, After that, I want you to link your findings to the lit you had up above. So then I go on and link here, Alson and Cossett, 2007, proposed strategies to engage girls and such. So somehow link your findings to the lit, and then implications for practice. Because I don't have any statistical significance, so there are limited implications for practice of this study. This study wouldn't necessarily be published. I would like something to say about the population and an association, but that's fine. But the implications for practice, really kind of work on that if you can, to dive. What does this mean, and what are the outcomes of this study mean for a practitioner? How would I take what I've learned in this paper and use it? And that's what we're trying to do in the implications for practice. Like I said, my paper ended up total. When you don't take the abstract into account, there's 1, 2, 3, 4, 5, 6, about 6 pages, and the total count is 2,000 words. Yours doesn't have to be this long. So if yours comes in at 1,000 words, I'm okay with that. It's about process, but I want you to hit all the steps in this. That's the key important